We good? Oh. Are we good? Oh. Are we good? Oh. Okay. We seem to be good. Okay. I need to edit this title. So this is going to be Minecraft remote control. We're going to be trying to anybody here? Damn, just me. Damn. Ooh, you know what? Hold up. Okay. Is this video, like, is this frame rate okay? I mean, the frame rate seems okay. This, is that, that's not it. That pipe wire, I need to tell pipe wire what it is. There we go, yay! Okay. So, Minecraft. In the Open Computers mod, there is a in the Open Computers mod, there are computers. Whoa. What are they called? Screens. So we first need to build a computer in this mod, which requires a couple things. Ooh, EEPROM. Where's the EEPROM? Google BIOS. Memory, CPU, disk. We need a hard drive. There's a hard drive. Oh, we also need a floppy disk. There's the. Oh, there it is. So we have the operating system, we have the CPU and graphics, we have memory, we have the EEPROM for the BIOS, and finally we need a disk. I found it. And some cards. Actually, no, this isn't. We're not going to be actually like using this. Well, maybe, but we're mainly going to be using a robot. So this will turn on, and ooh, slap the keyboard on there. Oh, this is tiny. This is not usable. This is not usable for editing. So I need to change the levels on this. Like that? Okay, that seems good. Okay. Yeah. That seems better. Okay, so reboot. And so the first thing we're going to do, first thing that we're going to do is create the file that we're going to be remote client.lua. Control S press Control W. Remote client. That works, but this is not what we're not going to be using this. That's not it. Where is its folder? Minecraft saves this. Oh yeah, I've done this before, but I haven't done it in C++. So I want to do it in C++. Open computers. Oh yes. Home. Okay, remote. There it is. Okay. So if we edit this, come on. There we go. I'm running so many things. It's not. My computer's not liking. I should close some tabs. Ooh, maybe I shouldn't like close YouTube. My preview things. It's really not liking this. I'm gonna exit Steam. Industry. How many tabs do I have? I have so many. Kotlin LSP, I was doing like Mindustry things. YouTube? YouTube? Oh. Let's just wait for that. So if I change this, if I edit this, print, then I mean it shouldn't change because it's like loaded in memory. But if I shut down, I could have just pressed that. Then we do remote client. It's still okay. That's an issue because I don't want to edit in open computers, and I want to edit somewhere else. Is this cache? Is this in the cache? There's no way. Oh. Nope, never mind. Okay. What's this? What is PCX? I've never seen that before. Can you even open it? That is quite a lot of formats. And like FF play, PCB. Oop. That's not gonna work at all. Yeah, no. Where's it saved? It's not stats, data, advancements, dim1, dim dash 1, region, player date. No, where is it? This should be, but it isn't. Is it? Okay. I mean, there's probably like. I'm not sure. Anti-lib bin okay. wget. I think that's what I want. There's no curl, right? Okay, hold on. Redstone. Sort by name. Yes, which... yes. What does that do? Is there a no? There's just yes. There's just yes. What does this do? I'm getting sidetracked, but I want to know what this does. Yes from GNU Core Utils? I am sorry? Yes. Okay. Yes with the command line arguments. Oh! What? Wait a second. I have 2 Alacrity terminals that aren't free. Okay. What if we do yes? Oh wait! Wait, that's cool. Okay. Okay, let's do this. Let's do this. That is cool though. That is very cool. wget command. I know this is like a webget, like it's used to download stuff. Host. How do I wouldn't be netcat, would it? Can you use... How do I... Okay. Serve single file. How do I serve one file? I want one file. Only one file. Wait, netcat. Is netcat here? Am I just blind? Fine, paste in. What is RC? RC, I feel like I've heard that before. Thanks. Huh? RC open clears? Netcat. Oh. I'm trying so hard. I'm trying so hard to be able to use an external editor. OPPM. Huh. Okay. Uses magic 6Ks.
Interesting. Library for vectors. Oh, I guess like... Okay. There's a lot of things here. Excuse me. That's what I want. Do I have Node installed? I do. You know what? Can I just like... Oh! I might be dumb. I might be very dumb. There's more here. Whoa, okay, that works. Insert. Sure. You know what? Sure. Oops, I didn't mean to do I don't need to do that. There's no way this works. Yeah, no, okay. Can you like, okay. No, game mode. Okay, there we go. Okay. Remote client. Let's call it R. Let's just do the things. Maybe we should like start doing the things that I started this to do. Wireless network card. This is like internal to the world, right? This, yeah, that's not. It's like TCP. Redstone card. Network card. No. Internet. Yes. Internet card. And do we want the debug card? Maybe. Maybe eventually. But for now, I mean, let's run our C++. See if it works. Should work. There we go. Now, so that works. And now we need to do sockets. Let's do some sockets. And how do we do that? C++ does not have standard networking, so we're going to be doing some pure C++ programming for now. I'm gonna model this after Rust's like thing. I don't know after what Rust does. I believe it's like so TCP stream, and we need an IP address. And our IP address, actually, it's going to be I know what it's going to be. It's going to be a variant over this. Okay. I'll just update the title. Like that. So we have an IPv4 address, which is 32 bits, 8 octets, and then this is going to be unit 16T. It's gonna 8 of them, I think. Hexadectuplets. Let's call them parts. IPv6 address. Let's actually look at what an IPv6 address is. Wikipedia. Give me a second. Excuse me. IPv6 address is of size 128 bits. So that's like, yeah, 16 times 8 is 128. There's 8 parts. Oh, IPv6. I love IPv6. It's so cool. It's so cool. Okay. We're gonna make both of these public. I'm gonna make the member public and the constructor public. We should accept both an array and an initializer list, I think. 8T4 octets and initializer list. Is that right? No. I don't think so. Okay. No. Wait. Hold up. So how does this do things? How does this constructor work? Go to, can I go? Go to definite? No definition found for 3. Great. Does this work? Okay, that does work. That just brings me to, okay, never mind. Array. Oh, I see. Wait. I don't see. What? Wait, what the? Wait. template array, template class, wait, class equals new. This is just all templates. Is this encased in anything? What is this encased in? This is the struct array. Huh? Can you do that? Wait. Array int wait. I'm so confused. What does this mean? What does this mean? Okay, I'm getting sidetracked again. I need to stop doing that. To array. What? Oh. Oh, I see. Huh? Where's array? Okay. Interesting. Okay, we're just gonna accept this. Standard array of unit 16t. And it's gonna be parts. Parts and parts. Why? Oh. Has to be 8. Right. And then it can be public. There's no invariants that come with this, so it can be public. IP adder, IPv4 adder, address, data address, and we do the same thing with IPv6 address. No, we don't do that. Okay. I was thinking, like, do we allow arrays? No, we explicitly make that. A TCP stream. So we are going to have the socket. What is it? It's like maybe like Berkeley sockets. There's POSIX sockets. Sockets is POSIX, right? Yeah. Wait, is it? Berkeley sockets evolved with a little modification from the de facto standard to a complement of the POSIX specification. Okay. BSD and POSIX sockets. So. Oh, wait. Socket. Socket. This will give us an int socket file descriptor. Socket file descriptor. Ooh, actually, socket fd. Socket. Wait. Include syssocket.h. Okay, and this will give us this function, which has domain. The domain is AF. There are a lot. There's Bluetooth? There's a Bluetooth one? That's okay. DECnet? DECnet, okay. Oh. wait. Domain. No. Int domain. And that will give us return standard hold alternative IPv4 adder data. Actually, no, we'll call this storage. AF inet 6. So if it doesn't hold an IPv4 address, it'll hold an IPv6 address. So that's the domain that matches the domain. Address domain type. A type is, we're not going to do datagram. Wow, there are a lot of options for this. I need to look into this like sometime. Sock stream, sequenced reliable two-way connection-based byte streams. An out-of-band data transmission mechanism may be shorter. So this, I think, is TCP. That's TCP, right? In protocol. Is non-block different? Non-block appears to be a flag. But I'm not gonna... No, we don't need it. Sock stream. What is protocol? What's protocol? Protocol specifies a particular protocol to be used with the socket. Normally, only a single protocol exists to support a particular socket type within a given protocol family, in which case protocol can be specified as 0. Normally, only a single protocol exists to support a particular socket type within a given protocol family. So, in which... What? Before I go into this. Huh? What is this? Oh, they're errors. There's C errors. That's interesting. Didn't know that existed. The protocol's definition file? That's not a command, right? No. Ah, yes, the protocol's command. Get proto-ent. I don't think I had to do this. I don't think I did this last time. Socket protocol. Let's see, socket protocol. I might just use like a different thing. Where's an example? Use the socket example. Oh, ooh. Create a socket with a socket system call, which that's just that's the manual. I know that. Ooh, client.c 0. Do we just go 0? Do I just put 0 here? I guess I just put 0 here. Okay. If socket fd less than 0, then error could not connect Socket. Cannot create socket. So the client side, we also need a TCP listener, which could not create socket. Connect socket FD struct sock adder. Wait. Construct sock adder. Okay. So we're going to create a sock adder. Struct sock adder in. Ooh! It's in sock adder in. Is it sock adder in or? I don't really get this. What? Netanet. Is it? Net inet. Wait, are there different sock adders? Ether adder. I have ether adder octet, eth alien. That's no. Netanet in. So that defines sock adder in. Yeah, it does. Yay! That works. In adder. Return. Sock adder in serve adder dot sim family. Ooh, dot sim family equals what's this? SA family. Wait, are these shorts? Are they? Are they shorts? Where are they? AF max is AF max. You know what? I don't know standards. I don't know like what standards are in place. I don't know I don't know. So what I'm gonna do like that. I mean I don't know why I'm going through this. sin port equals H2NS. Oh, wait. Port. Is there anything else? B copy. I need, oh, okay. equals 3. Ooh, that's weird. I don't remember doing this. You know what? I'm going to okay. So we have a serve adder. Wait. We need to initialize this. Do we need to zero initialize this? C++ default constructor initialization. Are the compiler provided constructor will do nothing. Oh. Oh. What? So declaring. So if what? Aggregate initialization. Does that initialize thing? Does that like? So like if I do this, is that fine? Is that fine? Does that zero everything out? I assume so. Ooh, we need to set sock opt. Opt name. Oh, okay. That makes sense. So we've created the socket. We have created we set it to reuse sinadder.sadder equals inadder any. Sinadder, wait, no. Sockadder sinadder dot sadder equals. Oh, that's why it's 4. It's because we have in6. It's because this is different. That's completely different. Sadder equals should I assume? This is just going to be 0, right? Inadder loop back. So it looks like I'll have to, like... No. Wait. Endianness. I'm concerned about endianness. Like this, I don't know what the endianness of this is. What? That's just a function that doesn't exist. Okay. That's wait. Huh? Huh? What? Yeah, yeah. Well, sure. Inadd or any doesn't need H2NL. But... like this does, it doesn't need H2NL. But like... This was for network byte order as that for this constant use of H2NL. No, because it's already in it's already in network. Wait, it's already in network endianness. S-adder is literally just a UN32. Okay. Can we bitcast? We can visit. Let's visit. I have not used this in a while, but like variance. It's variance. What? There's no way that works. That's not, no, that's weird. That shouldn't, no. What are you talking about? Oh my god. Wait. Demonstrates the idiom of returning another variant. Huh? No. No, wait. C++. Wait, no. C++ match variant. Is that seriously how you do that? With deduction guide. What? No way. No way. No way that, no. No, there's no way this is actually how you do this. Standard visit. Address visitor. Let's see. Well, we don't need family anymore. We don't need the family function anymore. Static assertion. Kidding me. Standard visit requires the visitor to be exhaustive. Is it not? Is it not? Oh. Oh, okay. We're good. We're good. Standard bitcast. So we bitcast the adder. Socket FD. Why is this crossed out? Implicit capture of this with the capture default of equals is deprecated. Implicit capture of this with oh, right. That should work. So we connect to the socket file. We'll do that later. Don't feel like doing that right now. Here we go. Why is that like that? Here we go. Socket connect socket adder into construct socket adder. I assume we have to cast. Yes, we do. We have to cast. Oh, wait. I don't know why that wasn't working, but... yeah, reinterpret cast. Yeah. If connect is less than 0, then okay. So now we've connected. We can start writing stuff now. You know what I'm gonna do? I'm gonna I'm gonna make a Rust thing to go alongside this, and we're going to test our connection. We're going to test our socket by connecting to this, because I know that the Rust one is going to work. Actually, listener. I don't even have a TCP listener, so like having one that already works. Excuse me. Like that'll work. Actually accept. That work? That works. Okay. And n is greater than 0. Buff. Wait. So this should be a very simple, just like netcatter kind of thingy. It just takes in things, prints to the console. And now what we can do is actually, we don't have a TCP listener yet. So we connect. We're just gonna do this, and that'll allow us to just stream. Wait, we need to input the header. Include socket.hpp and the stream IPv4 adder 701, and so I know we're big. So if my endianness stuff fails, then I know, I know if I got my endianness wrong, then I'm near 100% sure that this will fail, because that's how this works. I should add another constructor for this. IPv4 adder. And then octets, octet 0, octet 1, octet 2, octet 3. There we go. Then we have the port, and now int sockfd equals stream fd write what is it? It's, I forget the header for, oh my god, what is it? Is it like sys.io? I forget! What is it? Right function Unix. Or Linux. Unistandard, that's right. I knew it was like some sort of like, something like that. Right sockfd. Didn't even do it right though. Hello 5, so we should get like 5 lines of text in here. Do we close it? How do you close it? Close. Close. Sockfd. Cargo run. Run. And. Oh, yeah! Let's go. Okay, perfect. Is there a sleep? chrono suffix literal. Chronoliterals. Yeah, I don't know. Using namespace standard literals? Is that a thing? Oh my god. That is interesting. Cool. And from what I've seen, okay, something I kind of want to try. Something I want to try is quer. Not starting with underscore or reserve. No, I'm going to go with this operator. I kind of want to see something. Invalid. Oh, it has to be that. So do you have to do that? Weird. That's a feature that's really weird. That's a feature that's really weird. That's a feature that's really weird. I don't know if I don't know if I like that. I mean, okay, that works. This should work. This should work. Oh, wait, hold on. Yay! There, T-H-E-R-E. Yes. Okay. So what happens if it? Oh, yeah. Okay. So we got everything working properly. Now we need a destructor. Actually, no. First thing we need is write. You need an iterator of bytes. Do we need an iterator of bytes? Or does it just need to be... Don't think it needs to be an iterator. It can be... span for now. Probably add more types. Probably initializer list. But for now we'll do span. Span is nice. We'll probably do iterators later. If write bytes dot data include unistandard. If write socket fd bytes data bytes size bytes, because why not? Value of type void is not contextually convertible to bool. Huh? Oh, we need to do that. That's right. And this returns -1. Wait, size t. So we're doing size t because, okay. So we're doing size t because if we get less than 0, then we throw. Do we throw? Do we throw? Do we throw? Is that yucky? Is that yucky? I feel like it's yucky. I don't know. Connection interrupted. Do we need to close? If so, you know what? Okay, let's write the destructor. TCP stream. Action. Okay, TCP stream const TCP stream RHS equals delete. So we'll delete the move constructor and copy assignment operator, but we will implement the. So we'll delete the copy stuff, and we'll implement the move stuff. Socket fd RHS dot socket fd RHS socket fd equals 0. 0 is valid. Equals -1. If socket fd is greater than 0, socket fd equals -1. No, greater or equal to 0. Close socket fd. So free it once, and we love. Is replace a thing? I know swap is a thing, like swap two things. Replace is a thing in Rust, where like you replace, like you could pass in like RHS and then -1. It'll get RHS, it'll get RHS and return that, and then set RHS to -1. I want that. I want that. RHS.socketFD, RHS.socketFD equals -1. There we go. That should be the rule 5. Turn this. I'm not doing that anymore. Stream.write. This new span. Char. Does this work? We're just going to allow passing in strings. Right. I don't know if this is overly strict, but we're going to allow that. This, right. We need a span of uint8t. It's going to be string dot data, I guess. No, wait, it's just a pointer. String, and we need to import span. Standard span, no matching constructor, not satisfied. Okay. We need to do this, not standard. Please? Reinterpret cast from const char to uint8t casts away qualifiers. Oh, you're so right. Oh my god, you're so right. I forgot. Does that work? So strlen times size of char. I mean, that should work. Size of char should be 0, and size of uint8t should also be 0. So I don't see why not. Turn this dot right, and now we can just write strings. Hello, hello, and then we will string right there. And then we'll not do this because we already have a destructor. Then we'll run our program and see if it works. Please. Please. Yes! Yes! We got it. Okay, we're cracked. Oops. We're cracked. Okay. So we have TCP communication. Can we get it working in Minecraft? That's what I want to do. Let's. Okay, I need to pull up like the Open Computers docs for this. Computers docs. Let's move this into a new window. Put it somewhere. That is tiny. We're not gonna do that. We're gonna move our Minecraft there. Official documentation of Open Computers. Where is... The :3 doesn't really do anything. It's just text. Where is it? Is it this? No, that's not it. That is not it. Configure application launcher. Yeah, you can just add text here. Like, where is it? Where's the TCP? Where is internet? Yay! What? Internet. Oh, this is the tiniest window ever. Wow. I don't, like, what do I do with this? Do I, like, hold on. Do I get a lesser screen? I think I might get a lesser screen. You should be able to change the, Oh, that's way better, actually. Internet. Okay. Internet.open. Internet.open. We need a TCP listener, I think. Actually, hold on. I'm going to use my tester, my Rust tester, to try and see if I can... Oh, does this even... Wait. Opens a buffered socket stream to the specified address. The stream can be read from and written from using read and write, and generally like files. Wait, I need to do like... Wait, hold on. Okay, so... First thing is we need VS Code. Why are you doing this? First thing we need is 127.0.1 228. Does that work? S. Can we write to it? No, we can't. Oh no, we can! Look at that! We did it. Okay. exit. So we know that we can... It's not connected anymore. Huh? Can we... What? Oh, exit isn't a function. Control D? Okay, it times out. Okay, this is working. This is working. So now we have things that can connect. Close that. So now we have things that can connect. We need something that can listen. So we have... Is it literally just the exact same thing? It feels like it is. Public TCP listener. Sock stream protocol 0. Server. Listen. That's what it is. That's what it is. Okay. That's what the function is. So when we do this, also do that. We need to set reuse on. And visit again. Standard visit. And it's not. It is. It is a sock adder in. S in family, S in adder. Ooh, you know what we could do? Const expr IPv4 adder any. Const expr static IPv4 adder any. Does that work? Is it partial? It's incomplete. Const expr variable cannot have non-literal type. Incomplete type is not a literal type. Okay. I get it. Language doesn't want me to have fun. IP adder. See, but that doesn't work either. Namespace net. We do it like that, and then we need to specify net TCP stream net IPv4 address. IPv4 adder v4 any equals. These can be const expr. I need to mine my constness. I need to mine my mutability. No, that's not const expr. This doesn't change anything, so it can be const. But will it be const? Maybe. I think so. These don't need to be marked const expr because you can't even use them. These can be marked const expr because they don't call external functions. This one can't though. This one also can't. That looks good. This all looks good. Now we need to connect, I guess. Bind. Oh, we need to bind and then listen. S in port equals H2NS port bitcast address. Looks like exactly what we've been doing. If bind socket FD. This is literally just the exact same as bind. Size of. Yeah, it's literally the same thing. Socket field to bind. End connection request will be queued before further requests are refused. Return 0 on success and -1 for errors. If listen. So prepare. We need to accept. Accept, that's a function. Okay. Connection. And of course, this is int because it int defaultness. We'll set this to 4 for now. You can specify more if you want, but we'll do that. If listen is less than 0, throw standard runtime error. Failed to begin listening. CPU listener failed to bind. TCP socket failed to connect. And we'll put IPv6 on here. Failed to begin listening. New sock FD equals accept. You know what? Hold on. TCP stream. We can construct a TCP stream out of just a socket file descriptor. TCP. It's friends, right? C++ friends. Is it, oh, it's like friend class TCP listener, and then TCP listener. So we have a private constructor, because this can, because like passing in anything for the file descriptor is an invariant, so we won't allow that for the public API. Socket FD, and instead we'll only allow TCP listener to do it because this is perfectly okay, but Microsoft. That's hilarious. That's actually hilarious. That is perfectly fine, but under specifically Microsoft, this doesn't work. That is okay. Where is right? TCP stream accept. Accept. Oh. Ooh. Right, okay. adder. Do a pair. I don't have v4 adder and TCP stream. Except and we need ooh. No, we can just do IP adder. Well, no, because we also need a port, don't we? Do we need a port? I don't even know. I don't even know if we get a port. Except socket sock adder in foreign address except if except new FB equals accept new address. Cannot initialize a parameter of type struct sock adder with sock adder in. That makes complete sense because we're in C++ land. Why do I keep putting standard in front of that? It's not standard. Huh? Huh. Wait. Excuse me. What is this? U32 type. Oh, what? Std type. If sock T address length accept doesn't matter. S adder. Well, this is in network ordering. I think. Yeah. Network order. So we can bitcast this into standard bit. Can we just do that? No. Can't weak inference. Weak inference. Okay, so we have the address. We got the port. Wait a second, we got the port. Hmm. Okay, address. Wait, no. Wait, no, yeah! Yeah, cause it thingies. It thingy. Socket address. Expected semi-break. That. Why is YouTube re-encoding to... Wait, is that this? I don't know. So we... Storage. Does this work? Yeah, it should work. This should be good. This should be good. It should be good. It should be. We're going to take in a socket adder address. Address visitor. Socket adder. Turn. So, socket adder, IPv4, and then
port. Oh, port. N2HS. New address. Listen port. Does that work? Does that work? TCP listener. Stream. And connect to IPv4. Destructor! We need a destructor! Oh! Wait, is it the same thing? It's the same thing. Okay. Okay. So we can just copy and paste the, copy and paste the rule of 5, but paste the exact same thing. TCP stir TCP listenering. Real. We just copy and paste the same thing 10 times to replace. Then net TCP stream listener accept screen. Right. Auto adder net TCP. Wait. Stream equals that. So we do some unpacking there. Stream right. Sleep for 100 milliseconds. I mean, this should work. I don't see why it wouldn't work. But I'm gonna test it in Rust because I like Rust. Let not stream, and in Rust we're going to TCP stream connect 7.828. I'm gonna connect instead of bind because this one's binding to that one. First of all, check for seg faults. Check for like anything that goes wrong with this stuff. Okay, it's working. And then yeah. Okay. We did it. We have wrappers over sockets. And now we can communicate in Minecraft, hopefully. Lua S equals internet open 1.7.0.1.2.8 and then moment of truth S read. Yes. Okay. So we've gotten bytes from the remote to Minecraft and back. We can do and it goes back and forth. So we need to create a Lua program now. So we have read and we have write. We need. Wait. We need to create an object. Function make byte. Make. What do we call it? Make binary. That's what it's called. So make binary stream. Turn
write u8 equals function end. So we need to make stuff now. Open computers. Let's invite. Number, and this should be, oh wow, what is that? Why did that happen? Why did that happen? String.byte. Read u8, and we want to wait. S equals string read 1 byte. Read u16. This is going to be network endian, so S equals that. So we send the high byte, and we send the low byte. So this should be S byte 8. Yay! Okay, that works. And then read U32 should do the same. Well, wait. Only has one variable, but you set two values. Yeah. Read u8 and shifted by that. Read u8. Read u32. 16. Read u. Oh wait, no. I want to read u16. So okay, that's how questions works. String from byte. Excuse me. I burped. I'm sorry. Okay, what the heck? How do we create? How do we? How? How make string from byte? Me want make string from byte. I don't know how to do that. Byte, okay, strings can contain any 8-bit value. Based. That's true perfect.
Is this the entirety of Lua? Wow. String manipulation. Good God, excuse me. That's funny. Yeah. String.char. String.char. 40. 50. Okay, that is exactly what I want. Write U8X. Great. Dastardly. Wait, no, that's not. No, that's what I want. That's what I want. I want to shift it by that. Write U52. Write U16. 16. That works. Seems like it's working. An undefined global string. Function stream flush end. Flush. That seems like all we'll really need. My legs are bouncing because I'm caffeine. Stream equals make binary stream. I feel like this could work. Print stream 2. Oh, that's right, because it's making a thingy. It's making a thing. I didn't want it to do that.
I don't want to do that. I don't want to do that. Hey, I did a thingy. Okay, so we can read a U32, and it will be in. I mean, we kind of constructed big endian. This feels like it should work if it goes into here. Which will be arm dot lua edit r dot. Nope. Sure. Edit r dot lua. That's great. Insert. What is the error? 38. Do I not have 38? Do I not have internet? Do I not have internet? I thought I have internet. Oh. I just kind of accidentally vimmed. So I didn't do that. Wait, I didn't do that right. Hold up. Let's edit it in here because yeah. Where? I might change to CC tweaked. I don't know. Don't know what's going wrong.
Is it that I'm not connected? Wait, hold on. Edit R. TCP. No. We'll listen.
Didn't even try. Is it not what? Why? There's no error message. I'm dumb. Lua uses that. That's still an awful, like, that is still a straight up awful error message. Errors in this are terrible. Why? Is it? Wait, what? Am I dumb? No. Am I? No. Wait. Whoa, okay. Oh my god, what am I doing? I should be using colons. Why? Why am I not using colons? I'm dumb. Seems to work. Crashes because I disconnected. But we should. Okay, edit r.lua. Print stream read u32. Stream, so we'll write 2 bytes. We'll do this. We'll do 1,000,000 just so that we actually. We'll do. Does that work? Okay. We'll do that just so that we. So we'll do 1,000,000,000 just so that we cover all 4 bytes. And R, that's 1,000,000,000. So we did it properly.
bytes, octets, and then Lua will write a U32. Ooh, should we make it? Okay, so what I connect. Right, U32. Right. Huh? So write U32 calls write U16, which then calls write U8, which then calls stream write. That looks fine. I'm being dumb. Meta method sure? What's wrong with sure? What's wrong? Oh my god. I know exactly what's going wrong, actually. It is dot. It is dot. I'm keeping it like this, maybe. That worked. No, I'm not keeping it like that. I know exactly what's wrong. What's wrong is... I've been doing this wrong. Slash. And this is all copied into here. This makes a lot more sense. This feels way better. I'm not really used to Lua, but this feels like way better than whatever I was doing before. And now if we do write U32, it should, do I have, okay, no I don't. edit r.lua, and we insert all of this. That looks okay. And now we head over to here to our TCP tester. Cargo run R doesn't work. Why doesn't work? Why doesn't it work? Why doesn't...
No! No, that's wrong! That's wrong! Bad, bad, wrong!
Okay. In meta method index, so something's going wrong. In write u8, was I really? That's dumb. That's dumb. That's just dumb. In write u8, right. You know what I'm also used to? Freaking putting a thingy putting a variable name inside of a structure or an aggregate initializer initializes, like, Rust and JavaScript do this. If you put the name of a variable and it's the same name of a field, you can just put the variable name, and like this in Rust and JavaScript is equivalent to this. I'm speaking to no one, but that's okay. Arm r.lua, edit r.lua, insert, and this r. Oh, no. Okay, please. Is it working? Is it working? Is it even what? Oh, I forgot. Edit r.lua. Yay! Amazing. We need... template type name t... no. Template size t n. Array un8t and read exact. So size t read into a span constant 8t, no, into a span of uint8t bytes const read socket fd bytes data bytes size bytes. If n is less than 0, throw standard runtime error. So connection interrupted if this.
condition connection. Oh wait, this has to be const. There we go. Neat little function. Read. So read exact, it constantly reads until ooh, okay, so size t left. So bytes left equals bytes. And it's, yeah, size bytes. And then read into subspan. Does that work? Okay, so we have 10 bytes. This feels simple enough, but we have 10 bytes. We read 4. Oh, ooh. What was this? So we have 10 bytes. If we read 0, it's gonna flop. But we read 4, and so size bytes minus bytes left. That's 0 first, and then 10, and so size minus bytes left, which is 0 first, and 10. Then we get 4. Bytes left is 6. 10 minus 6 is 4. That's good. 6 gives us to the end. That's good. Then you read yes. This should work. Size t right exact. We're going to change this to already read because it feels easier to use. No. Wait. Yes.
plus and minus already read. Equals 0. Turn out. Wait, what? Hold on. Does span contain, or does this contain? Okay, does span contain a constructor for array? Oh my god, it does! Yes! 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 Very happy. Read array, read exact, return out. That's it! That's it! Don't really know what else. You know what we're gonna do? So, wait, hold on. Edit r.lua. Okay, we're going to read 4 bytes, then bitcast that into a uint32. Standard print line. Standard bitcast uint32 t. N to h at no. N to hs over here. Stream read array 4, and that should give me, what if we do 5? Yeah, it fails. Cool. What does bitcast require? Thank you. Oh, okay. Is trivially copyable, is trivially copyable. Cool. N2HS, we don't write. We don't sleep and we don't write. I don't sleep. I know that for sure. Let's run. C++. Okay, now R. No. 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 Wait. Oh. Into HL. I'm sorry. Yes. We are so back. Okay, so we got this far. We got a TCP stream and TCP listener going. We can read and write, communicate with Minecraft, communicate with other TCP stuff, and we need to make a protocol now. Protocol is going to be fun. That's going to be interesting. Okay, I think that'll be it. I think that's it for now. Bye, I guess.